This introduces your proof. It introduces what you're working with. In our case, we're going to be working with sums of series. I mentioned yesterday not all inductive proofs are going to be proofs of sums of series, but because we're in chapter 9, that's where we're introducing this idea of an inductive proof. They're going to be related to sums of series. In your let statement, you really have like 2 bits of information. You have the long work of the sum of the terms in some sequence. So 2 plus 7 plus 12 plus 17, add up all the terms. When it gives you this 5n minus 3, just a good reminder for like what's happening within your proof, that represents some a sub n, like a rule for your sequence. So I could find any term in my sequence. You could do 1, like let n equal 4. 5 times 4 is 20, minus 3 is 17. And look, first term, second term, third term, the fourth term is 17. So that 5n minus 3 is just generating those numbers that are getting added together, right? That's your a sub n. The other bit of information in the s sub n statement is the formula for the sum of the series, which is what we're working to prove. So the sum of the series is equal to n times 5n minus 1 all over 2. And that's saying if I did 2 plus 7 plus 12 plus 17 and I actually added up n numbers, that would be equal to my sum. Okay, so once you introduce your proof to everybody, you're ready to get started. I'll have for you on your test on Friday 3 spaces. It'll say step 1, assume step 2. Okay, so what's step 1? What are we going to do? Verify for n equals 1, plug in for s sub 1. Okay. So show your work. Label it. S sub 1 equals. Don't plug into the a sub n. Plug into the s sub n. Everywhere you see n, plug in 1. 1 times 5 times 1 minus 1 all over 2. This is going to be 1 times 4, which is 4 over 2, which is 2. How can you determine if that was right or not? Where can you look? In your let statement, what is the first term of your sequence? 2. So the sum of the first term is 2. Did our formula verify? Yeah. So I always just say which is true. Just to kind of confirm. Yep, that works. Okay, so remember an inductive proof, that's basically us knocking down the first domino. The work that we do from here on out is to prove that one domino knocks down the next domino for all cases. So after step 1, you're going to have a spot where it says assume. It'll look like this on your test. And does anybody remember, what are we doing in the assume section? We're changing things up just a little bit. Yeah, we're letting n equals k. We're trying to prove now that one domino knocks down the next domino, but we don't want to do it for like a specific number of dominoes, like the 5th and the 6th domino, because then we still have to prove all the other dominoes. So we're going to say for any number of n, let's call it k. Let's show that k knocks over k plus 1. Okay. So we're going to assume, go back to your let statement, and just let n equal k. S sub k equals 2 plus 7 plus 12 plus 17. Also plug in k over here in your formulas for a sub k and s sub k. be a specific number, but we're going to call it K. Now, I recommend then that you write your show that. This is really important for us as beginners so that we know when our proof is done. That's probably like sometimes the hardest part about proving things is like, when am I done? When do I stop? Should I keep going? Have I finished? So let's say what we're supposed to show that through work. We want to show that if S sub k is true over here, if S sub k is equal to k times 5k minus 1 over 2, then S sub k is equal to whatever I get when I plug in k plus 1 for k. So that would be k plus 1. K plus 1 times 5 will be 5k plus 5. And then minus 1 will be 5k plus 4. So when we get to something that looks like k plus 1 times 5k plus 4 all over 2, we'll know we have proved what we needed to prove, and we could say it's true for all. If you look up a real proof by induction, a lot of times it won't say what the show that is. They'll just say this piece here, and then they'll do the work for S sub k plus 1, and in the end it will equal what S sub k plus 1 should be, but they let you do that work in your head. And so as beginners, it's good for us to include it so we know when to stop. Okay, step 2. Now you're going to do the work for that. So you've got your assume, and you've got what you want to prove. And we're going to show all the work for S sub k plus 1. Remember in geometry how you couldn't like skip anything? You had to, every step had to lead to the next one. Don't try to shorten your proofs. You got to show all the work. So I want to show work like I have up here where the sum of k plus 1 terms is adding up all the terms. So I'm going to list out the sum of k plus 1 terms. Well, I'd start with my first term, plus my second term, plus my third and my fourth term. And if I was doing k plus 1 terms, I'd also have my k term in there. Okay, so I'd have my 5k minus 3. But this is only a sub k, and if I want to do the sum of k plus 1 terms, I need a sub k plus 1. So you have to do a little bit of work here in step 2. You got to figure out what the next term after a sub k is. There's a couple of different ways to do this. Can anybody give us one way how we figure out what a sub k plus 1 might be? Elena?
Sub in k plus 1 for k, so it would be 5 times k plus 1 minus 3, which is 5k plus 2.
Yeah, you could sub in k plus 1 right here in the formula. Like this is how you generate the different values in the sequence. So put in a k plus 1, multiply it by 5. That's 5k plus 5, and then minus 3 is 5k plus 2. Now, I'm protecting those with parentheses in this example just so you can see, like, those are individual terms, right? A k term and a k plus 1 term. Does anybody see another way that you could tell that the k plus 1 term was going to be 5k plus 2? Noah?
Since you know that it goes up 5 every time, you can just add 5.
Yeah, this is going to be like my shortcut way. So if you're always looking for, like, something short, something easy, something fast, this is the way to do it. If my first term was 2, how did I get to my second term? Add 5. If my second term was 7, how did I get to my third term? Add 5. If my third term was 12, how did I get to my fourth term? Add 5. If my k term is 5k minus 3, how do I get to my k plus 1 term? add 5. 5k minus 3 plus 5 is 5k plus 2. Okay, so whichever method you like, use that. If you need to write something down in your notes so you remember how you got the k plus 1 term, go ahead and do that right now. Okay, so essentially in step 2, you're doing all of the k terms, but then you're adding a new term, right? This is new and extra. Okay. The next step of this proof is look for a match. You've seen 2 plus 7 plus 12 plus 17 plus 5k minus 3 before. It's up in your assume, right? So all of this is really equal to k times 5k minus 1 over 2. So I can make a substitution for all of those terms. Now I can't include the k plus 1 term in there because that's an extra term. But I can go all the way up to 5k minus 3 and say that all of that was equal to k times 5k minus 1 over 2. So that's what all that green stuff equals. We assumed that to be true. That was like our given, so we can make the substitution. But we still have this other extra term, plus 5k plus 2. Remember, that's like yesterday when we had a sum of 357 and we wanted the next sum, so we would just add an extra term. Sure. Thanks. Christian, can you run to Mr. Steele's office? Front office area. So this is like saying the sum of the first 17 terms, and then I want the sum of the 18 terms, so I add an extra term. And now, once you get it down to this, the rest is just algebra. You're just manipulating things. So what you really want to do is like group things together. In order to be able to add anything, we're going to need common denominators. Because this is really like 5k over 2 plus 1. So I'm going to multiply it by 2. I can keep my denominator of 2. And then to be able to add this stuff in the numerators, I'm going to have to go ahead and distribute. So that's going to be like 5k squared minus k plus 10k plus 4. Which that simplifies to 5k squared plus 9k plus 4 all over 2. Remember, at this point, I'm just manipulating algebraically. I'm not really like now focused on my sequence and series part. I'm just trying to get down to my show that. I've done all the work I need to do above. You should likely come up with a trinomial. There's one proof on your homework that's a little bit different, so if you get to that one, you can ask for some help with it. But you'll likely get down to a trinomial, and then you're just going to want to factor. So to get the first term of 5k squared, it must have been 5k and k. To get this last term of 4, I have a few options. It could be 1 and 4, 4 and 1, 2 and 2, 4 and 1 is going to give us our middle term. So we would get 5k plus 4k, which is 9k. Now, you've got this in its factored form. Go back and look at your show that statement. So right underneath assume, did we get to the correct s sub k plus 1? Yeah. We're looking right here. K plus 1 times 5k plus 4 all over 2. And down here, is it okay that they're out of order? Sure, multiplication is commutative. So we can say thus, s sub n is true for all n. Yeah.
So this is kind of like what Noah did when he added 5. From the original, you had 5k minus 1 times k over 2, and now you added 5 to that analysis term of 5k, and he's added 1 to the k to get the correct. So is that kind of like the same thing?
are you like referencing what we did to get this one, like plugging in k plus 1?
We had a 5K minus 1, then we had a 5K plus 4, and that's the adding 5 again that we had earlier.
Yes.
So I was just making a correlation with that.
Yeah, I don't know. That'd be interesting. You could look at that when you're doing your problems tonight. I don't know then what the connection for the next term. Then you would add 5. Yeah, I see that. Yeah. But just side note, you have to show this work in between, right? Because this is not just like a question and answer kind of thing. This is a proof. So you gotta show the people, right, who are reading your proof, you gotta explain to them every single step. So you need to show the sum, you need to show that you can substitute in for the series up to k, add the extra term, and then combine like terms, and it should equal your s of k plus 1.
Do you want to show how you did that first line again? Like the where it says equal k 5k minus 1 over 2 plus 5k plus
This one?
Yeah.
Okay, so yeah, up here, when you start step 2, you want to add up k plus 1 terms, right? So you got to show this long work where you add up all the terms. And you can model it after s sub k, but the only difference is, of course, you have to add this extra term here at the end, right? This 5k plus 2. But between that step and the step below it, you're playing like what I would call like a matching substitution game. Every single time you guys do this, because we're continuing to do series formulas, you should be thinking in your head, 2 plus 7 plus 12 plus 17 plus 5k minus 3, that seems awfully familiar to me. It is my s sub k, right? So it's the thing in the assume. So then for all of these things, I can just write them as the sum, k times 5k minus 1 over 2. So I'm playing a game of substitution. These things match. Therefore, I can put in k times 5k minus 1 over 2 for that. But I still have that extra term because this would only be the sum of k terms, and I want that sum of k plus 1. So I have to add the k plus 1 term. Good question. Anything else? Okay, your homework assignment is 5 proofs. You have the rest of the class period to work on them. You should stay focused and work on the proofs so you can ask questions if you have them.